Welcome to the Unstructured Data Meetup. Thanks so much for joining us today. And first of all, I want to thank our lovely hosts, SAP. So they are providing us a spectacular venue and also all the wonderful food and drink. My name is Chris, and I work here at Zillis. And I run the marketing and community group here at Zillis. And so the first thing that I want to say to everybody is if you're interested in being a speaker at one of our events, just hit me up or Sachi or anybody that works at Zillis. We hold these meetups every month. We have them here in the South Bay, San Francisco, Seattle. We just did one in Berlin a couple hours ago. New York City and Shanghai, and we're going to do Brazil in a couple weeks. Frank's actually going to be speaking, and then we'll be opening up Tokyo and the UK, London pretty soon. So lots of opportunities to come and speak to the community. So what I'm going to do is just talk a little bit about, or hopefully inspire some of you so that you will come and speak to our meetup by letting you or reminding everybody that, you know, what's really happening right now is we're in this kind of really exciting gold rush era with GenAI. And when we at Zillis think about GenAI, we think about these three pillars. We think about, of course, all the models, right? Everybody now knows what all these different models are. A couple of years ago, most people didn't. And then, of course, you know, thanks to the success of NVIDIA and ARM and Intel, et cetera, we also think of computation. But really, there's another really important pillar to GenAI, and that's data. And in particular, unstructured data. And so you'll notice that we actually call this meetup Unstructured Data, and it's very intentional. And that's because we feel like there's a lot of tools out there to manage structured data. We've been doing it for years and years and years. But with these new models now, we can actually get some incredible insights into unstructured data, which we all have a ton of, even just on our own laptops, right? We have lots of notes that we've been taking for years and years and years, all unstructured data. And if you're like me, you probably named it something completely different 3 years ago and you can't find anything, right? You just know there's some cool diagram in that one thing that I wrote. Where the heck is it? Maybe I should write a little a RAG application to help me find these things. So we have a lot of unstructured data, and on top of that, a lot of corporations also have even more unstructured data. So I think everyone's really excited about the possibilities of being able to get insights from unstructured data. And of course, one of the ways that you can do that is with the use of a vector database, which is now like the hot thing. If you talk to my friend Chris over here, I think he has a list of what, 100 vector databases? Of course, I work at a company that builds a vector database, and I'm actually thrilled that there are so many vector databases because that just tells you how incredible vector embeddings are and the possibilities behind them. But vector databases are useful because we can actually store those embeddings and do a semantic similarity search, right? We want to look for things that are nearest to the thing that we're searching for, so we can find things that are semantically similar. So very, very powerful. I work at a company called Zillis, and we are the maintainers of open source Milvus. And Milvus is, of course, it's an open source project, so you always have to name it after an animal, right? That's just what we do in open source. Milvus is actually a bird that can fly really fast, really high, and has really great eyesight because we're trying to get insights into your data. And also, when you think about unstructured data, it's not 10,000 vectors, it's not a million. When you're going into production, it's easily going to be 1 billion, 10 billion, 100 billion vectors that you're dealing with. And we have to make sure that we can actually process that data and actually do our queries on that data very, very quickly. But in any event, Milvus has been around. I think we open sourced the project in 2019. We donated the project to the Linux Foundation. And because we donated to Linux Foundation, we had to come up with a new name for the company. And so we made up a name, and it's Zillis, and it sounds for zillions and zillions of unstructured data. And if it were up to me, we would have named the company with the number 1 and then Zillis, but we're at the end of the alphabet. In any event, a lot of well-known companies that are using open source Milvus, so please check it out. And we actually have many flavors of it. We have an embedded version that you can quickly put into a notebook and get started. Or if you're ready for something that scales, you can go into a Kubernetes version of Milvus as well. So the big use case that everyone's talking about, of course, is RAG. Who has built a RAG application? Who's thought about building a RAG application? Probably everybody here, right? So I'm not going to go into too much details about what retrieval augmented generation is, because we have a couple of talks that's going to go into a lot of details about it. But one of the things that I just want to articulate here is that, last year it was really the hot new thing, and it was primarily based on text. This year, we're actually seeing that it's much more not just text-based, it's multimodal, so images, videos, audio. And actually, our second speaker today will actually be building a multimodal RAG application. So he's going to walk you through, and this is Yi. He's going to walk you through how that can be achieved. But there's more exciting things that are on the horizon. And so if you look at a number of the papers that are out there, or you talk to another people that are starting to really build this in earnest, there's also going to be some merging of use cases. So merging recommender systems with RAG to build some really powerful applications. And, with vector databases, of course, RAG, recommender systems, drug discovery, fraud detection, autonomous driving, there's a lot of use cases. And I think that's why everyone's really excited about vector embeddings. So going back to these three pillars of GenAI, everybody knows all these big model names now. Everybody knows all the hardware guys that are out there. And on the data side, of course, we're here, got to talk about a vector database. But what I want to leave you with is that if you look at the world of structured data, there's lots of databases, but there are a lot of other tools that help you with data ETL, with generating pipelines, with generating security, compliance, observability. There's a ton of tools that are available. And so hopefully you'll start to think about, hey, maybe I can build something that's going to help in this space and, kind of complete the picture, if you will, for unstructured data. And so once you start working on it, let us know. We'll put you up here, put a mic on you, and have you share your project with everybody here. And I'm sure you'll get a ton of really great feedback. And plus, it's just going to be a lot of fun. So once again, these meetups are intentionally called unstructured data. So we're all about building out the community and trying to, foster some innovation with all you guys, because I'm sure all of you have some really great ideas or some really cool burning desire to build that next great tech. And yeah, come join us and come to one of our great meetups. So, and then we'll also be doing a summit towards the end of the year in San Francisco. So with that, I would like to introduce our first speaker. And so Kate from SAP will be speaking. And Kate has been working on the GenAI team at SAP. And so what she's going to share with all of us is the work that they've been doing, and I think also maybe even a product demo. Okay, let's welcome Kate.
Thank you. Okay, 1 second, sorry. It says it's paused, like the screen sharing. It was working a second ago, though.
Yeah, we did test it out.
about that. Yeah, so my name is Kate. I am a developer with SAP SuccessFactors GenAI team. We've been around for like a little bit less than a year, so still a relatively new team. And if you don't know, SuccessFactors is SAP's human capital management software. So we do everything from people profiles, compensation, job posting, learning recommendations, setting goals, pretty much anything people management or HR related we have. And today I'm excited to share with you the value that generative AI has in our HCM suite and also my personal favorite use case that we've created so far. Okay, so our approach to generative AI is really about integrating. Huh? Is it not? Is it not? My okay. Oh, it was echoing from there. Okay, the mic wasn't on. Okay, so we've all like played around with ChatGPT. We know that that's free. Everyone, there's what makes it, how can we get our customers to actually buy into using generative AI? We charge our customers per AI unit. So how do we get them to actually make use of this? And it really comes from integrating our business data with generative AI. We get a lot of value from that. So for example, using skills data to generate a job description. You don't have to worry about typing in all the skills. We can just grab that. Our data scientists use prompt engineering and fine tuning in order to generate the most valuable prompts for each business use case. And we also test a large number of models with different settings. So every individual use case is using the best possible tool. So we have a variety of use cases implemented all across the SuccessFactors suite, including job description generation, performance goal generation, and a virtual writing assistant. And we have many more to come. So my team really works with different module teams to set up use cases that are most valuable to them with our business technology platform, which is how we access various LLMs. So the use case that I want to share with you today is our assisted person insights use case. So this is to help generate compensation insights for our managers. So when it comes to having a discussion about compensation with a direct report, there's a few things that can be challenging. For one, there's just a ton of data and like everywhere, like we were talking about. There's so much data to compile. Where do you look for it? How do you get to it? You have to think about history of job progression, compensation history, one-off bonuses. And not only that, you need to situate all of that data within each company defined pay grade individually and for that specific role. So not only is this super time consuming, but you can easily miss things because we're human and we have human error. And additionally, it's just a very like sensitive conversation to have. So it can be hard to know where to start. And so with our tool, not only can we quickly synthesize all of this information and generate either hidden insights that we maybe didn't notice or just a good summary of them, we also offer different talking points for managers of how to get the conversation started. And then my favorite part about this use case and what I find the most interesting is that not only does this help a manager have an efficient conversation with an employee, but also an equitable one. So we know that compensation is not something that is fair in life, right? Age, gender, like religion, everything affects compensation. And unfortunately, we as humans are inherently biased, even if we don't think that we are. So our perspective or our perception of like who someone is might affect how we believe they're being treated, if they're being treated fairly or not. But with an LLM, if we take out some of those descriptive factors, which I'll talk about a little bit more, we can get a neutral look at compensation and job history. So I think that's a really cool benefit. Okay. Sorry, I was on the wrong slide for that one, but okay, I'm gonna hop right into our demo so I can just show you what this use case looks like in real life. So for this case, I'm going to be Jeff Hill, and he is going to have a conversation with two of his employees today about their compensation. So the first person I'm going to look at is Jada Baker. So this is what SuccessFactors looks like. I'm just going into her people profile. As her manager, I have access to all of this information. I'm going to go down to compensation. So in the past, this is pretty much what I would start looking at, but they're just like some random numbers, a graph that doesn't have a lot of information. I'd have to spend a good amount of time like trying to figure out what does this salary look like compared to other salaries? What does this progression really mean? Is it good? Is it not? But instead of worrying about that, I'm going to just click this magic button. I always need to acknowledge that I know that these are being AI generated. These are AI generated results. And then in just a few moments, we have a bunch of information. So at the top, we have a summary, just like some information about when she started, a bit of history about her compensation changes. Then we can see in the insights that she has a good compa ratio. It's increased over time, so she's being paid pretty fairly for her company. She's received some one-off payments, has had some good job progression, so she's done well at the company. And then according to the pay band position, again, she's being paid fairly. So talking points for her are going to be that she is being paid fairly, and that maybe if she does want to get some raises in the future, we need to look at further job progression. And then at the bottom, we just have our data sources so we can confirm everything's accurate if we feel the need to. So the next person that we're going to look at is Stephanie Thorne. And Stephanie has a bit of a different story. So when we get into her profile, we can see it looks a little bit different. So you can see here that the graph kind of plateaus a little bit, but luckily don't need to take the time to figure out exactly why or what that means. Again, just clicking the Generate Insights button. And again, at the top, we have our summary, some basic information, but we can see that these numbers are very different. So her compa ratio is 43% to 51% increase, so super low, potentially underpaid. Though she has received one-off payments and has had some good job progression as well, she's definitely being underpaid. And here's where I would maybe be worried about how to address this with her, but luckily can I look at the talking points that have been given to me. So I do know that I need to explore the reasons behind this consistent salary because it shows that she hasn't really received a raise in a while. And also address this underpayment because that's the only fair thing to do. But to keep it positive, we can also address the one-off payments and the job progression because she has done well in that regard. And then this does seem a little bit funky that she hasn't received a raise with our mock data, but you can tell here that this is in fact true. She has not, your salary has stayed the same over the last 4 years. So that's a little bit of insight into a couple of different use cases. Or a couple of different people and how this could be useful to a manager. And then just some other things that we considered as a team when working on this. I talked a bit about taking out bias when it comes to compensation. And so we also know that LLMs are inherently biased whenever they are trained on biased data. So we know that if we do include something like gender in a prompt, then we're going to get a gender biased outcome. So we can remove those things and play around with that to get the most equitable responses as possible. We also always follow security and ethical guidelines, protecting user data. And then we as developers play a big role in testing all of our use cases. We all work together to perform lots of post-deployment testing, keeping an eye out for hallucinations, anything that's a non-grounded response. And then, like you saw at the beginning of the demo, we always inform the user when GenAI is being used just in case, because it's never 100% accurate. And all in all, basically, GenAI is here to stay, as we all know. And we really want to make SuccessFactors an AI-first HR system. So we have a ton more use cases to come. And as we talked about before, there's so much data when it comes to people management and people profiles that we haven't even touched yet, and including a lot of unstructured data. And AI is going to really be our greatest tool moving forward to make use of all of it. So we're super excited for everything to come and everything that our team is working on. Yeah, thank you. I can answer any questions about that use case or other things that we're working on.
Hi, question on the composition insights. The text generated, are they generated by AI or?
Yeah, the text is all generative AI. So none of it is like everything is AI generated. I think maybe like the top header is like hard coded. Everything other than that is generated. Yeah.
And is this based on the historical base salary of the person? Gender on the different parameters?
Yeah, so it's based on a number of different things, including the historical pay as well as like company history. So yeah, like a number of different parameters around compensation. Yeah.
What if the hiring manager really want a candidate, and then can he intervene? And if he intervene, and then without going back to the AI system to adjust the model?
Sorry, what was it exactly?
The hiring manager,
Yeah.
if there's a human in the room, so initial AI recommendation of the compensation.
Oh,
And then if the hiring manager really want the candidate, really want to hire him, then he may be able to adjust the AI generated result. And if he adjusts, would it adjust going back to the model somehow?
do you mean like if you adjust like the history like in the system, or what do you mean by adjust? So like the compensation recommendation isn't, there's like no way to adjust that. We do have like measures in place for that. But maybe I'm misunderstanding the question.
I mean, so it looks like if somebody, were to look at the recommendation that you
Yeah.
presented, and maybe hiring manager didn't agree with what was being stated.
Oh,
can
yeah.
you like override, that?
So the thing about, the first thing is that all of this information, the only person who can view, who can generate insights is like, you can only generate insights for your direct report. You can't generate it for yourself. You can't generate it for someone else. So a hiring manager wouldn't even necessarily be able to look at that. I don't think we have anything right now in place for you to go in and override, but it's purely a recommendation. So, you take everything with a grain of salt and you wouldn't have to like base anything off of this. This is just to like help a manager get the conversation started. The outcome is completely up to them in the end, and no one else will actually be able to see these recommendations.
Any other questions? Oh, any other questions?
Just a follow-up question. What is the downside of this system that you have seen so far? Because now you are exposing all the details that were buried somewhere. Now with this, it's going to come up, it will surface out, right?
It'll what?
It will surface out all the details that initially was not available to the user or to the manager.
Yeah. I mean, again, yeah, this is why we definitely restrict like who can view this data, because I guess, you might not necessarily want to like your employee to see themselves that they're being underpaid. But yeah, like that's why it's really restricted to who can see it. And like, I think we believe that, if someone is, being paid unfairly, like it's good for you to know, or if there is a topic to bring up. This is really information that you could get to on your own, but maybe you didn't have the time, energy, effort to get to that in the past. So, I mean, if there's a downside to like the truth coming out, maybe it's a little bit more work, but I think all in all, like, you're just getting information that you would have to work a bit harder for in the past to get.
Hi, I have two-part question. So what LLM model do you use? And does it have hallucination like the other models?
Yeah, so I can't discuss exactly which LLMs we use, but we use different ones depending on our use cases. So we work with a bunch of different large language models and we test specifically for every individual case. We do see hallucinations sometimes, though we keep like the temperature a very low value or 0. And we like do extensive testing. So we haven't seen any issues like at this point with like numbers being false or anything like that. And with our compensation insights use case, actually, I think we've seen like very few issues. Yeah, but that's why we have a lot of people in the loop the whole way through to ensure that it doesn't go to production with hallucinations. And if there is something, easy way to report it back to us as well, and we'll look into it.
Yeah, this is a similar, that's the very general, like when the user uses your system, so they know that this is the content is not 100% accurate. So do you have some place show that, okay, this section may not be very accurate?
Um,
How the user understand the system is not like 100% accurate?
So we don't have anything that'll say like, this doesn't look quite right. That's why we have that AI acknowledgement in the beginning so that the user knows that this is AI generated. And like, if something does seem weird, then they might know that maybe it's an issue with the AI. But that's why we also include that section at the bottom with all of the data. And that data isn't generated. That data is like pulled directly like from our systems.
The reference, like
Yeah, so there's a reference. So if you were to look at the data and like a number up top and those were different, then you would know that like an error occurred and to regenerate. But again, we haven't seen any issues like that so far. And we do like a lot of work to make sure that the LLM doesn't hallucinate or generate false information.
Hi, excellent presentation, by the way, thank you. And I have a question about generated answer validation process. Would you explain a little bit more how you validate the result of the model? So for example, you got a report, and how did you choose which model to use? So what is the validation framework itself?
Yeah, unfortunately, I'm not able to like super specifically discuss this, but we do have an internal tool that we use where we can run various models, you know, against various prompts with different data, evaluating for groundedness, and run with all of those different settings. So we do have an internal tool that we're able to use for that. And our data scientists work hard to make sure everything looks good. But yeah, unfortunately, I can't discuss anything like super detailed. But if you are interested later on, we can connect after this and I can get you in touch with the data science team and they might be able to share some more. I'm not totally sure where my boundaries lie with that.
Thank you. And just from the product's point of view, I think if you have already all reference below with the table, maybe it's a good idea to put some citation in the answer. So I think it works well, like in Perplexity, for example.
Yeah, that makes
It's
sense.
exactly from where it was picked up the data.
Yeah.
Because when you show the graph, for me as a human, it was a bit easier to see on a graph and make some assumption rather than read the plain text.
Yeah,
Not
that makes
format.
sense.
Yeah.
That makes sense.
Thank you.
Yeah, that makes sense.
Thank you. Can you talk a little bit about how you use Milvus or Zillion in your system? Like how exactly you're using the vector DB?
So I don't work I think that's more of like the data science team side. I'm not totally sure. We're definitely, we're not using that tool, but I think it like depends based on the different use cases. But yeah, that's again like something I can't totally talk too specifically about right now, but I can also put you in touch with our data science team if that's something that you're interested in.
Cool. Any other questions? Oh, we have one more as we walk back there. I mean, I think one of the things that I appreciate about what you built is it's not always easy to have some of those conversations, right,
Yeah.
with other humans, especially if it's bad news.
Mhm.
So being able to get, some prompts, I think is pretty useful.
Yeah.
Yeah, it's like not exactly a question, more of a process workflow that I'm thinking about. Is it more like you are using LLM to augment stuff, like pull up all the statistics first using Zilis or any database that you have, and then feed that to the LLM to basically generate the text? Is that what it is used over here, or is it more like the model itself is trained on all the data and there's no augmentation involved?
That's again something I'm not sure exactly. I can share how detailed. I've been told to keep it a bit more strictly to the product side for this. A lot of it is still pretty new and confidential, but yeah, I could also put you in touch with the data science team if you want to know.
Yes, thank you.
If you want to know.
Yeah, great talk, by the way. Thank you for giving it. I realize now you probably can't answer this question, but
Yeah, sorry. I know this is a little bit less technical of a talk,
yeah,
but
it's okay. But are there any tools that that you can talk about, in terms of building out this application, or if there aren't any tools that you can talk about specifically, are there any ones that you prefer in the ecosystem, such as maybe Haystack or some of these other open source projects?
I honestly haven't looked too much into them. I'm excited to learn more today and do a bit more in the future. But we do split up our work pretty heavily between our developers and our data scientists. So they cover a lot more on that side. We're starting to work a bit more closely together, but that's kind of where we are with that.
So what was fun for you on this project?
I think for me, it was kind of, seeing it from start to finish, I just think we take into account so much data. And I think what I wanted to show here is really that the power of using GenAI with data, we can get so much value from it in just one use case. This is just one possibility of so many. And like I said before, I think it's interesting, something where it's a decision-making thing where we have inherent human bias and trying to take that bias out of the LLM. I think that's a super cool topic and something I'm excited to explore more in future use cases that we create.
Excellent, cool. Well, thank you so much. Let's give her a round of applause.
Thank you.
And if you have any other questions, she can connect you with the teams, or she can probably talk about some of these things offline. All right, next we have Yi, who is one of our developers at Milvus, and he's going to show you how to build a multimodal RAG.
Wow. Okay. Great. Let's get started. My name is Yi. I'm a software engineer at Zetis. Today my talk is going to be about multimodal RAG with Milvus. My talk will have two parts. The first part will be a brief introduction to RAG. I saw a few of you, actually a lot of you, raised their hands on the previous question about the RAG, but still that a few of you do not know what a RAG system is. The second part will be a deep dive into implementing the retrieval part of the RAG system. If you have a multimodal RAG to be implemented, we will try to implement that with Milvus. So here is a brief introduction to about what a RAG system is. So a good example where we use RAG system is a case where we have a lot of documentations, and we do want to ask questions about those documentations, right? Because the volume of the data is too large. You cannot send everything to the LLM. It's going to be slow. It's going to be expensive because OpenAI charges you by number of tokens, and also it may be beyond the capability of the LLMs. So what we do is to chop the data into small chunks, and then we do embedding to convert those data into vectors. Then next, we're going to insert those vectors into a vector database. So at the query time, we first also do the embedding for the query itself. Then we get the vector. Then we search the vector database to find relevant information about that query. Then with those response, we can organize the relevant documentations together with the query itself into a request to LLM. Then so that the LLM only needs to process data that is relevant to your original question. So that's roughly what a RAG system is. So it has three parts. The retrieval part is where we build the indexing was and to retrieve the relevant information from the vector database. Here's an analogy between a traditional search system against the RAG. A typical traditional search system has two parts. It also has a indexing building part where we have the data crawler or HTML parser and indexing building where we organize collect the data from everywhere and somehow we build a indexing for those data. And at query time, we also have components to process the query itself. Then we also have the index server, which loads the build indexing from offline indexing job. And then we will also have a ranker so that you will have a list of relevant documentations or references, and they are ranked. You probably will see the top 20 in the first page, and because of the ranker thing. With the RAG system, it's very similar. We also have a offline indexing building part where we do the embedding for all the documentations, and then we insert them into a vector database. And that vector database will help you to build those indexing behind the scene. That's what Milvus does. Then at query time, which is online serving part, we also have something similar. We process query, we retrieve the relevant information about that original query, then we send those, the original question together with the relevant information to LLM. Then the LLM will give you the final result. The traditional search system can process beyond the text, right? So the traditional, so the previous versions of RAG probably only processed one type of the unstructured data. You can build a RAG system to process the documentations, or you can build a RAG system to process the pictures, etc. So we wanted to go beyond that with the development of the multimodal in the past month. We are able to build a RAG system over multiple types of unstructured data. For example, if you have a bunch of pictures together with the text description about them, what you can do is to build a RAG system that can process both text queries plus image queries. So that will be my next part. This part will be more technical, and I will try to go through all the Milvus APIs you will need if you wanted to build a multimodal retrieval for your multimodal RAG system. So this system is pretty simple. So here, this example is very simple. It only uses text and images. You can certainly extend that to other types of unstructured data, like videos or even the protein structures or audios, etc. So in this example, we're going to build a retrieval system that can do search with queries that could be text only or image only, or a combination of text and image. So here is a result we expected. You can send a query. Here is an example of text only query. The query itself is a sentence. It is text in French. It basically means brown leaves during daytime, and we expect the system to be able to understand it and return you all the images. So before diving into the details, I need to provide a little bit of background about what Milvus provides, and we also want to know how to install that. So Milvus has two versions. Milvus Lite is a local version of Milvus. So it's to install it, all you need is a pip install. That's it. Pip install is all you need if you are only building a quick prototype or a small experiment with a small amount of data. Then that's it. So if you have larger data sets, then you will need a second version of Milvus, which is a distributed version. So we provide distributed Milvus in Docker's Kubernetes. You can deployment in either way you prefer, Docker, Kubernetes, or Helm. And if you have knowledge about how how to work with Kubernetes, then the scalability will not be an issue. Scaling the system down or scaling system up will be a trivial thing for you. so that you can, so you don't worry about the data, data side increase or organic growth, etc. So yeah, this is, I'm not going to dive into details. If you visit milvus.io, we have very detailed instructions for you to follow so that you can deploy your Kubernetes cluster or a local version of Milvus. So the data we are going to use is from Hugging Face. It's a data set with 25K images together with text descriptions about those images. So the first step of building this retrieval system will be to create a collection with Milvus. A collection in Milvus is very similar to a table in a SQL database, which means you would need to define the schema and build the index for particular columns if you want to speed up the search performance. So the step one is to connect to a Milvus. If you have it, if you have a Milvus Lite, then you need to connect it to a local host, right? That's it. If you have a remote Milvus cluster, then it could be running on GCP or AWS. Then just provide the address, the host, the port. Then Milvus will handle it for you. If you are using a, so ZS also provide a hosted Milvus service. It's pretty much a SaaS product. You don't need to manage the database by yourself. You can just click buttons and we will provide those database for you. Then the API will be very similar to this one. Just with one line code, you will be able to connect to that database. And the second step will be to actually create this collection. We need to define a schema. So if you look at the details of this schema, we have the primary key, which is ID. You can change this to string. It's really up to you. But it must be a unique identifier. Then we have two vector fields. So those two vector fields store the embedded vectors from your original data. In this case, we have two because we have text and image. So one vector column for the text, another for the embedded images. Then we have the last two fields, which are pretty much the original data. Because once you get a response, you do want to fetch the original data to be able, so that you can put those original data into your LLM request. So this is a very common practice. Like if you look at the image path, we only store image paths because the images are pretty large. You don't want to store everything, the original image, into your vector database because that will cost too much bandwidth, etc. And for the chunk part, for the chunk field, the last one too, because it's really very short, it's just a short description of the image, then you can just store it in the vector database. So it's really up to you and making decisions on like how much resource you want to be used in your system and what kind of performance you expect. So this is very flexible. So after defining the collection, then this collection API will help you to actually create that collection. And after that, we need to build an index for both vector columns. Here we choose cosine as the metric type. Cosine and L2 are the two most widely used metric types. Well, it really depends on what kind of data you want to use. So you can choose either cosine or L2. So this part is very similar to like a traditional SQL database. Last part is column.load. This load API basically tells you that I want to load this collection into memory. Then so that after the load, then I can start to run search or queries against this collection. Why do we want to have this API? Can we do that by default in our design? The answer is no. What we want to provide is the flexibility for the customer to decide which collection to be loaded into memory. So this API, so there's another API which is called collection.release. It just simply release all the resources from the system. For example, if you have a collection that will not be used in the next month, for example, then you can do column.release, and 1 month later, you can redo column.load. You don't have to do rerun the previous steps. The column load will be able to load everything to memory again. So this load release feature is very useful if you have a very large distributed system with a lot of collections, or you have a multi-tenancy system where you have a lot of different users. Then as a administrator, then you can decide, which one should be prioritized in terms of using all the resources. So the next, so now we have this vector database created and all the collections created. The next step is to actually insert data into the system. The step 3 is to do the data embedding. So this part is really, it really depends on what kind of embedding model you use. It also depends on what kind of library you use. Here is a very simple example of using some random models. So once you get all the embedded vectors, then step 4 is to do the insertion. So this part is a little bit long. It has 2 parts. The first part is actually putting all the vectors and original data into small batches. That's it. It's just glue code to put them into small batch. And then this 1-line code does the insertion. So actually, this 1-line code is all you need. So this insert API is very convenient, but usually the batch is small because you don't expect large volumes will request in a short period. But what if you have the large, like if you have a much larger batch of data, what you can do is to call a different API, which is called bulk insert. This bulk insert can be very efficient if your data size is super large. And okay, then to here, we have finished the offline indexing part. We have embedded the vectors, we have created a collection, and we have successfully inserted all the data into the vector database. Then the online part will be to do the actual retrieval. And this part, hybrid search is the API, that's it. It's 1-line code. So this hybrid search will help you to do the multimodal search. So if you look at the request program, it has image request and a text request, right? They are optional. If you only provide the image request, then we will do a search with image only. If you keep the image request empty and only provide a text request, then we will do a query with text request only, or you can have a combination, right? So next we're going to show you some result, like what the system will look like if you do those different type of searches. So here the query is text only, and the query is brown leaves during daytime because the model is able to handle different human languages. So even if the query is in French, which is different from the what we have in the database, it's still able to handle it. The query will give you relevant images. And this is the second type where we do the search with an image. It's only image, there's no text or anything. Then the returned result will be relevant images of cats, different type of cats. And third one is a example of using text plus image, which means none of the request field is empty, right? Then in this case, the Milvus will do search for both the image and the text. And then internally, there is a re-rank algorithm running so that in the end, you will have a combined distance. We probably should not put it on cosine distance here because it's actually a combined re-rank score. And that's roughly how things work. And we have went through all the important APIs. So yeah, this is how you build a retrieval component for a multimodal RAG. Then then next, what you need is to just put those return result into a LLM request and send that to LLM. That's it. So yeah, that's pretty much it.
Any questions?
Hey, thank you, Ian, for the presentation. So when you do multimodal embedding and you have like, talking about text and image, you have two vectors, separate vectors, and you have to index them separately. But when you search, can you combine or you have to search? Like, for example, in your example, if you have image and the text, do you search image first and then text, or do you do the other way around, or do you combine them?
That's a good question. So when you have multiple, like in this example, we have two vector fields, right, text and image. What happens is that we do search in the text column with your text input. Then we do image search in the image column with your image input. And afterwards, we do a re-ranking processing. So, because you have the scores from both columns, then the ranking will give you a combined, like score. So yeah, that's roughly how it works. Like we do, the step one is to do search separately in both columns. Step two is to do a fusion, which is ranking.
So is the order has implications? Like if you do text search first versus image search?
They run in parallel.
All in parallel. Okay.
Yes.
I see. Gotcha. Thank you. And another question. Like how, so for when you do batch loading or like small mini batch loading, how is the index being reviewed? Is that kind of a scheduled job, or how exactly the index is being?
Very good question. So the question is that if we insert data, do we run a asynchronous job to process, to rebuild the indexing for the new data? So the answer is that we have different mechanisms to process it. It really depends on the consistency level you want. You can specify the consistent level. For example, if you have read after write, then you want a very strong consistency level, right? Then you can specify that. In that case, the data index, so from your customer perspective, the indexing will be built instantly. So you will see the result that contains the data you inserted, just 1 second ago. Yes.
Oh,
okay. Yes. Yes. So in the case where we have bulk insert, I mentioned, where the data size is very large, and then in that part, there's no consistency level guaranteed. It's actually eventual consistency because the volume is too large. You cannot pause the system to wait until data is finished, right? In that case, then there will be a asynchronous job processing indexing. Yes.
Sorry for one more question.
Sure.
So in general, like how the vector DB is caching, like compared to traditional relational database, you have a caching mechanism for like, well, how is the caching being done, or is there anything that?
The question is about the caching. You mean the caching of the search result or etc.?
Like, if you have caching, you might not need it to kind of like getting an index from like, our disk.
Yes. Yes, we do have like a cache in the very low level infra. So basically, it's why it works as like just like what you described in the case where the data is not changed and the request is the same, then we just return the pre-computed result back. Yes, we have like a LRU cache to do that in every single computation node. So that's done at the single node level. It's not at a distributed system level. Yes. Yes, it's at a lower level. Yes. Otherwise, because if you do that at the distributed system level, it will be difficult for you to tell whether data has changed or not. Right. Otherwise, it will be expensive.
Do you want to talk a little bit about GPT cache for RAG systems?
Oh yes. Now, GPT cache is a high-level cache. That is also a open source project we provide. in our like GitHub page, basically, if you think that OpenAI is charging too much, and there will be a lot of very similar requests from your customers, then you can use GPT cache as the cache layer between the vector database and your front end requests, right? So what it does is to simply cache the result from the vector DB. If you have a lot of very similar requests, then that will save you a lot of tokens.
It actually works with a number of vector databases, not just Milvus.
Oh yeah,
So,
yes, independent.
and then we built it because we got in trouble, right? Because we spent a lot of money at OpenAI, and we're like, why are we doing that? Why don't we cache, right, the queries and the responses? And also we realized, oh, that's going to make it a lot faster too. So it's another. If you go to our repo, you can find that project.
Hi, for this multimodal rack, can you give an estimate like how much time does it take to build it and test it out?
Oh, so you mean the develop time
Yes.
for a system?
Yes.
So if you're only talking about writing the code to finish the implementation part, I would say it should be like 1 day should be good enough. 1 day should be good enough. If you're only talking about the data implementation part, but the actual data processing will be slow if your data size is super large, because if you think about the embedding process, you essentially need to do embedding for every single piece of data. So yeah, so implementation can be very fast, but data processing will be still, especially the embedding part. Also, it depends on which embedding models you use or which company's API you are using. So yeah.
Hi, help me understand, like, so this is a vector database, and so the information about the images are stored there, but when you go and query it, you're returning all the images. So where are the images stored themselves? Is that like just on the file system?
Oh, so in this particular example, we only store the file path. Actually, it's a URL of that image in the DB. So when you get the response from the vector DB, it gives you, the vectors, the score, the chunk data, and the image file path. Then you can just retrieve it with this, file path. This file path is a URL. It could be, for example, S3 path.
Okay, and second question, like, what are like the limitations for the light version of Milvus?
Oh, good question. The question is that what is the disadvantage of using a Milvus Lite? Well, the obvious one is that it cannot handle the large volume of data. It runs locally on your laptop. I don't expect it to be very powerful in terms of handling large amount of data. So yeah, I think that's pretty much it. That will be a critical thing. So it will be very convenient if you are only building prototype, or if you are like running small experiments with a small amount of data.
Okay,
yeah.
thank you.
Great talk. Can you configure the re-ranking algorithm and
oh, sure.
Back to the previous.
Okay.
What was the strategy on the chunking?
Right. So today we only provide 2 types of re-ranking algorithms. I mean, they are the most popular ones. If you have like other ideas, if you want to add new, you can just totally send us requests from the GitHub page. So the first one is RRF. Essentially, it takes account into. So let me talk about the second one first, because that one is easier. It's average weighted scoring. Basically, you as a customer provided the weight for each vector fields. Then we just compute the weighted score. That's it. But you can see that if the score of different columns are very biased, then the result will certainly be very biased, right? Then that's why we have the RF. It computes the order of each column, And then we have, it's actually a very standard algorithm. If you just search it in Wikipedia, you can find it. So the essential difference is that it computes the order instead of the raw score. And then we just use some algorithm to combine them. So it helps to deal with the unbias between different column scores. Yeah.
And then your second question was on chunking?
Yeah, what was the strategy on chunking? If you have a large image?
Oh, I'm probably not the best person to answer the question because chunking will be, beyond the capability of vector database. I'm not sure if Frank is here, if he has better idea in terms of how to do chunking.
It's going to depend on, what your corpus looks like, right? I mean, you can go all the way down to like the token if you want, a sentence, a paragraph. You can also overlap, maybe just to get more context. So there's a lot of different strategies that you can take on the text. Yeah.
Yes, so there are a lot of libraries that provide you different or very popular chunking algorithm, like Llama Index, and I think I'm pretty sure that they have a lot of very popular ones. I would just simply refer to those public libraries to do it.
The other thing that you can do is if you grab a free Zillus Cloud account, you can actually use a feature called Zillus Cloud Pipelines, and you can actually chunk your data, and they have all these different options. It's just a nice playground if you want to, just kind of check it out.
Yes.
Any other questions? Okay, cool. Well, thank you so much. And you'll be here if you guys have more questions.
Yeah.
All right. Lisa, you ready?
If I say no, does that mean I...
No, well, then we'll make the person who came in last, they get to do your presentation. I think that's fair. All right, as Lisa's getting set up. Let's see. Lisa works at a company called Data Strato, and she's going to talk about what they're all about. And just looking at Lisa's background, it's quite impressive. She's worked as a data engineer, and now she's working in product at Data Strato. She's also a Google Women Tech Makers Ambassador, and looks like a big ambassador and a big fan of open source. So welcome. Thank you.
Thank you so much for having me. And thank you everybody for coming today. It looks gorgeous outside. So the fact that you're watching this is very humbling. Thank you so much. So I'm going to be talking today about metadata lakes for next generation AI ML development. What that means and what that looks like, we're going to get into, but there's a lot of new concepts in here that I kind of want to bring forth, but hopefully some of it looks familiar to you. So a little bit about me. I got a really great introduction already, but I'm a product manager at Data Strato. I have a technical background as a data engineer, and I am an ambassador for a few different organizations in the open source world, including the Continuous Delivery Foundation. I organize a group here called Data Engineer Things, the Bay Area. I'm also on the Linux Foundation AI and Data Outreach Committee, as well as the GenAI Commons Committee. A lot of what my career has been kind of looking forward to up until this point has been finding this weird intersection between DevOps teams, data engineering / infrastructure teams, and machine learning teams, because I think that there's a lot of incongruency around the way that these teams operate and the way that they communicate. So kind of to get into why I started thinking about this, and particularly in terms of the next gen AI ML steps, I see that a lot of the RAG that we see in demos and applications that we see are kind of at this POC level where we just kind of build this RAG pipeline, and then if you look at step A here, you just prepare the data. The data is just prepared. It just gets fed into this pipeline, and it's so easy. It just comes from this single source. It's already standardized. It's not messy. It's perfectly version controlled. Anybody who works in production with data systems knows that it is a complete nightmare, and that is totally not how it goes down. Everything past this point, I'm going to leave to the Milvus guys to master, but a lot of what I'm going to be talking today is how do we actually get a RAG pipeline into production with the data infrastructure piece in mind. So knowledge management within RAG is also inherently pretty difficult, especially at scale. It's hard to really get a measurable sense in terms of the observability. Even in the data engineering world, and obviously in the DevOps world, we've had observability for a while, but how do we get observability in terms of our actual machine learning pipelines? So what is the velocity of the documents that are coming in? What is the distribution? How do you version control and get the life cycle as people are editing their documents? And how do you actually trace that lineage in a way that's auditable? And obviously, sometimes you get billions of documents. How can you actually manage that in this super messy way with all of these sort of minute things going on? So if you are a data person, you might have heard of this term called data products, which is where you're sort of providing ownership to a specific team over their own data, and they're sort of expected to serve it to other people. I also want to kind of bring this concept into RAG as well, where when we think about RAG, we can also think of RAG as a product as well, right? How can we break up a RAG pipeline and any sort of machine learning application into reusable pieces? This is because in a lot of organizations, what I see is that R&D builds an LLM model and then tests it in like some sort of R&D environment and then passes it off to another team to productionize it, right? What does that even mean? And how do we actually make that reusable and break it down into its components in a way that's standardized? Kind of on top of this as well, RAG has itself gotten more complicated. And as we're doing research and development in terms of getting the best performance out of these models, we also have to think about how, the complexity underlying this will change how we take different systems into production and what kind of underlying complexities that will bring. So for instance, you might have really agentic based RAG, you might have advanced retrieval methods, you might have a mix of different things as well, like past just fine tuning. And all of this has many different implications and costs in terms of performance and in terms of, actual cost, right? So some of the challenges that you might face in RAG development, and especially when you're keeping in mind these things at scale, is of course having that trade-off between how complex querying can be handled and the actual time to return an accurate result. Obviously, the more complex your query and the more complex queries that you can actually use, the longer it's going to take to return a result for you, but the more accurate it's going to be, right? How you provide some sort of synthesis for incoming information over time. This also ties in with continuous learning and updating. This is extremely relevant in streaming systems as well. And this is extremely high velocity, especially when you're considering just how much is coming in and how can you keep things up to date, right? I think there's a huge difference between models that have access to data that's continuously updated versus those that are kind of stuck in time. And of course, with all of this, there's latency and performance optimization and the governance piece of it, which is how do you actually ensure data privacy and security, right? In that first sort of RAG POC, there's no sort of encryption, there's no masking, it's just kind of a free for all. And in real world contexts, you can't really do things that way. I also want to get into the difference in terms of architecture that we've seen over the years and the difficulties in terms of that as well. So for instance, in different clouds, you have different silos that occur. So over time, we've gotten so used to having one specific public cloud provider, or we might be doing things on-prem as well. But over time, we actually find multi-cloud architectures to be pretty common. Just the general messiness of things ends up that way. And nobody really likes vendor lock-in. And so you might have production-worthy pipelines, but only on GCP, right? Only on a very specific set of tools that can guarantee a baseline standard for you. But if you kind of deviate from that, it's extremely punishing. And so, how do you kind of avoid that lock-in? I think we mentioned before, I'm a big open source person, so I'm gonna definitely harp on that today. And over time, we've, of course, seen these infrastructures get more and more and more complex and looser, but also more structured in different ways. So we started out with a very structured, warehouse. As more unstructured data came into play, we played around with different formats. And, I don't even think data mesh is really that widely adopted currently, but there's like each one of these diagrams is much more complicated than the other. And I think that's something that we really need to keep in mind, because in that first diagram, that's just step one, data preparation, right? That doesn't really capture that much else. So including how many different cloud providers you have and different tools you have just running your infrastructure. You also then have to implement your actual architecture and how you want to serve this to consumers in your organization, let alone, actual application users. This is another point of complexity where tools have been changing a lot over the past 5 years. This is the 2024 ML, AI, and data landscape. This is not even the entire thing. I actually had to truncate the screenshot just because that was as much as it would zoom out. And each year there are more and more tools added. And so who are the ones that are most likely to adopt these new tools? It is the machine learning engineers, I think, right now. And architecture is slow to catch up. So how do you actually build architecture that can support all of these new tools that are evolving without necessarily building all of this technical debt behind it? So to kind of sum up, this is a terrible slide, but I think it's true in a lot of organizations that we have a lot of different silos at different levels of an organization. So obviously you have an operational silo that can occur just depending on who's working with what data and what's relevant in that sense. And especially if you're working in different data centers across the world that are, kind of type locked there. Of course, the different type of data and the format, I think that open formats are getting more popular now because this is such an issue, but really that this is hard, right? How do you operationally create consistency in your data across an entire organization? There's also silos within teams themselves. So a team of BI analysts versus a team of data engineers versus a team of, again, DevOps engineers will have access to completely different tools and won't even talk to each other. And they should be talking to each other, but oftentimes they don't. And they're all using different specialized tools within that specific system, which creates further technical silos as well, right? And again, this is part of that tooling silo where the language is so specific. Oftentimes I've met like DevOps teams that are trying to get into this idea of deploying machine learning applications, and yet they literally can't understand the language that machine learning engineers are using. And this becomes this further divide. So there's a lot of just messiness just beyond architecture as well that we can look at. And this becomes a huge disadvantage because if you're building a company-wide knowledge graph to power a machine learning model or an LLM that you want, you need unification of all that data at some level, and you need to manage it in an actually like solid way. And different teams are going to be using different execution engines, different data stores, and they're going to have their own specific way of doing it. And then you're managing your legacy data architecture on top of your modern data architecture as well. It's just a complete mess. But if you want like good performance out of your like LLMs, you kind of need to unify it and standardize it in some way. And if you want to productionize it, there's you need to govern it, right? And so how can we create flexible architecture that can account for all of this and still enable R&D to do what it wants to do and drive organizations forward with their innovation without totally telling them, hey, we have to wait like 3-4 years before the architecture can actually get into a place where the data quality is good and it's actually unified. So this has kind of been solved in a lot of ways through metadata. And the way that we've tried to do it is by creating metadata wrappers around different applications in order to then serve to organizations as well. This has kind of been really interesting in terms of how we create that layer. So if we go back here, you can see that there's a unified metadata management layer in between everything that sort of sits on top. And oftentimes, and the reason why I used metadata lake instead of a data catalog is very specific. And this is because a technical metadata management system will be very different from a consumer-facing metadata management system. And as part of that, we're seeing the differences here where instead of just having a common semantic layer that's like a business glossary or something similar like that, where people can pull and interact out of, we're having active metadata that's then embedded within different applications in these different layers that can be triggers to things like orchestrated pipelines, metadata analysis, observability. And of course, we see how powerful metadata is just within a RAG pipeline itself. And with that comes governance built in. So why is this really important, right? Obviously, there's data discovery, that's part of this, kind of knowing what data is available through having a catalog. But essentially, there's a lot of different parts of this that really come into play when you have rich metadata given throughout your applications. And if you can unify it and pool it into one single place, then you can have a single team manage it and serve it in a way that is actually useful to another team. And a lot of this is sort of, classifying your data in accurate ways, doing masking, doing metadata enrichment as well, and connecting, of course, all of these different sources together through like a unified architecture. And so I said that I was part of an open source project before. That project is Apache incubating Gravitino and Data Strato's kind of flagship repo that we pour all of our resources into. And so we provide a single metadata catalog that you can actually plug in all of your different sources to, and then use your query engine of choice to actually plug into as well. So it's a technical data catalog, and it's a metadata lake, because we kind of have a more loose approach to how we use metadata in terms of just being very prescriptive. So for instance, if you have, in your company Hive Metastore, and you have Amazon S3 buckets, and you have all of these different types of catalogs or different data stores, we allow you to then register it into the metadata lake and then control it, and actually have another infrastructure team manage it through that single plane. I'll get into this more a little bit later, but that's kind of the idea, is that throughout all of your different teams who are using this data in different ways, how can you create a single plane that then they can interact with while still having the guardrails there? So the idea of Gravitino is to have a multi-cloud architecture compatible data catalog. So regardless if you're on an AWS ecosystem, Microsoft Azure, Databricks, or GCP, or you're working with on-prem, you can actually interoperably work in those ecosystems without necessarily having to move all of that data into one single place. This is our federated querying approach. And then through this, you can have a layer that sits on top of all of those clouds and have things like access controls, data lineage, you can optimize queries, and then obviously auditing becomes a lot easier across different systems. And this is also really important if you're working with geo-distributed data centers. So there's a lot of really cool reasons why it's very useful for this, and it's very consistent, right? Our architecture is pretty straightforward here. We're very, API first at the moment. We do have a UI that's being built out currently that is more enterprise friendly. We do have a basic community UI though, but we were one of the first to build an Iceberg REST catalog, and we actually serve everything as a REST API for your different applications and teams to kind of push and pull with. And so the idea here is that underlying, you'll have a bunch of different connectors to different things. So let's say you have a Kafka stream connector, and you have, an AWS S3 bucket connector, or some sort of like JDBC catalog or warehouse, or other unstructured data. And then what that does is that it gets converted into a common schema and then registered into our catalog, which is then present into the metadata lake. The metadata storage currently is within cache, but you can plug in your own metadata storage, so it doesn't actually get sent to anywhere else unless you define it to be. And then it gets served within that one single layer. And you can also register models. That's something that we're currently working with, because we kind of want a full end-to-end view. And of course, this slide is a little bit more technical, so I'll kind of skim over it a little bit. But the point of this is just that in order to handle non-tabular data, we actually do use a virtual file system along with Arrow to be able to give you the same functionality that you would with your normal tabular data. And the idea here with all of this is that one team might use Trino, one team might use Spark, one team might just use a normal like MySQL setup. And we want them all to be able to query the same data in a federated way without physically moving that data to the same place, and actually have consistency between all of that. And that's kind of the idea, right? Is that you can serve it to any team, and then that metadata persists in whatever changes you decide. And if you have certain access controls over it, if you plug it into another framework, you can then have more fine-grained control, like row column masking, etc. So this is kind of our idea of what data governance is kind of going to move into as we talk about machine learning and AI governance as well. This is extremely important, especially if you're trying to have a messy architecture but move everything along a pipeline. And as we're bringing in different data transformation tools, we want to have this idea of how can you actually catalog your transformations? How can you catalog along those sources? How can you have that full lineage? And then once you're in production, how can you retain all of that in the same place, right? So I don't think catalog RAG is totally a real thing. I think that in what we would expect it to look like is that it would sit below, vector stores and knowledge graphs, because I think that hybrid formats are so popular. And the idea is, how can you really safely and in a nice governed way, without, really slowing down your machine learning engineers, have them do what they want to with all of the tools that they want to. And if they want to do a whole knowledge graph across the entire company, how can you easily set that up despite everything underneath being really gross, right? That's kind of the idea, is how do you have a catalog that then knowledge graphs can pull from, or that vector stores can pull from as well? And then can you govern within that? So our kind of proof of concept of what we've used so far in terms of getting this idea through, and we've kind of talked about RAG a little bit, but essentially our idea is down the road, we'd love to kind of have these built-in generic agents that are embedded within the catalog that can then interact with systems in a really intelligent way, in a tool agnostic way as well. We have a Colab notebook here that you're welcome to go through, and this kind of shows us being the backbone to Llama Index in this case, and having agents interact with our actual data catalog. We're still pretty early stage in sort of getting this through in a way that is super production ready, but this is our idea so far. We've focused so much on being this amazing data catalog that now we want to master being an AI catalog. So a little bit about our community and what we do. So again, I kind of talked about our idea being the bridge between a machine learning team and a data infrastructure team, right? And this is kind of where we've come from and where we're going so far, and how we imagine, these different teams interacting with us. But we also want to kind of make note that we have done so much work around the federated querying in multi-cloud environments. So again, we're trying to bridge everything across organizations together and allow tools to be used in the way that they should be used without having all of this technical debt behind it, with including global data compliance. So again, because of the federated nature of our catalog, you can query the metadata with the source data staying in place, and then the join happens either in memory or somewhere else where you define, and then you don't have to worry about it anymore. And you can also do tag-based masking as well for additional security, for whatever you need to do in terms of having that governance in place. And then you can also build data agents as well that can interact directly with Gravitino, depending on how you want that to look, either as generic or as specific as you want. All of the data within the catalog is available. But yeah, I think it was 2 weeks ago now, our vote to become an Apache incubating project passed. And this was really important for us because if you don't know, the past couple of weeks in the data world have had a lot of catalogs rise up very randomly. And this is something that we were prepared for, but it's worth noting that we open sourced our project on December 12th, 2023, and you can see that our stars have grown a lot, even way more since this screenshot was taken since then, which we're really happy about. And on June 13th, 2024, which is, I think, 2 days after Unity Catalog OSS was announced. Again, we're open source people, and so that contributor number is actually 100 right now. We raised from 80 to 100 within that short time. We have 187,000 lines of code versus at the time on June 13th, there were only 0.17K lines of code for Polaris and 25K for Unity. And the number of commits that we've had. So we've had almost 1,400 commits. I think it's probably way more than that by now, versus 2 commits and 2 commits on each open source project from Polaris Catalog and the Unity Catalog OS. Of course, over time, this will change. But to me, that's kind of like a README and like an update README pretty much. Like it's very bare bones. And, you know, in terms of issues, we have almost 4,000 issues at this point. And so we've been developing very openly, and we are vendor neutral as much as possible. And we think that there's a lot of silos that will occur depending on the favoritism and developer experience that different catalogs will offer. So that's kind of been our part. If you're interested in our community and more about Gravitino, you're welcome to join our community. We'll be moving over to more Apache-based community resources pretty soon as well. And so if you just want to start our GitHub repo, that's always a helpful thing that you can do to support open source. And yeah, if you're interested in contributing, you know, we have a lot of documentation out there, but also we do have a tag called Good First Issue. So if you're new to open source and you're interested in getting, you know, part of the community, that's always a great place to start. And yeah, we have also many social media links and websites. I'll let you just Google Datastrata or find me on LinkedIn if you want to. And we also have a very vibrant community of different users who are using us in production currently, as well as who are actively contributing code to us. And so, yeah, thank you so much for listening to me ramble. Yeah, so the actual boundaries are defined within the catalog itself. So you define the policies on your side, and then it's enforced through Gravitino. In terms of federated RAG, I don't know if we've tried a like pure federated RAG like pipeline in that way, but I think that it would be pretty much the same as any other sort of querying that you would do within the catalog. So we already support federated like analyses. So.
Hey, thank you, Lisa. Lots of catalogs recently. So just curious about why do you call it meta lake? Metadata is metadata. Why lake?
I think that a lot of it is because when we consider the paradigm of traditional data catalogs and metadata, we think of static metadata, but we want to kind of provide a lake because it's a pool, it's unstructured. And then, you know, it doesn't necessarily follow the same sort of paradigm that you would have seen in previous data catalogs. And the idea is that you're registering all of your sources and it's kind of being dumped into this one place, right? And so within that, you have your different like lake house kind of attributes, but it's also supposed to be more like unstructured data friendly.
Okay, well, it's just because when I see the name, I saw the metadata itself is a lake. It's actually metadata is not a lake. It's metadata managing data lake. So that's why.
Yeah, that's pretty much it. And I think I have another presentation that I do called Quick and Dirty Intro to Metadata. And metadata is such a large umbrella term. Like logs can be metadata, like anything can really be metadata. And it lives within small applications and it's just being spit out. And oftentimes a lot of metadata is not being actively looked at. It's just like not active or being used in any way. So I think with the idea of a lake, we're actively pooling it into one single place and then it's meant to be served. I hope that makes sense. Yeah.
Okay, thank you.
Hello, can you hear me?
Yep.
So I'm fairly familiar with Unity catalog and catalogs in general and governance. The way Databricks approached it is from an end-to-end pipeline, making sure that at every place they have governance and traceability and things like that. When you mentioned about RAG and later on, when you tried to kind of have an idea about the data lineage, at some point RAG falls short and then you start doing fine tuning and things like that, where it becomes very easy to figure out that from two data marts, data gets squeezed in and then there is leakage happening. So just having a governance and tracking of data on one side is probably not enough. And how do you, so this I think this problem is still not tackled, do you know if there's any solution which will address that in the future or in the pipeline where we also create a lineage of figuring out what gets escaped from the chute, in the sense that from the LLM side of things? This is a different challenge than just cataloging the data.
Yeah, absolutely. I think that one of the things that Unity Catalog will do really well, and it probably already does really well for its users, is that if you're using tools that are within the Databricks ecosystem, just like any other cloud provider, they will have all of that data captured and be able to afford some sort of safety with that. I think that, you know, like you said, this problem isn't necessarily solved end to end, but there are tools that are trying to solve it in each way. So I think ArangoDB is kind of one of those where it's a metadata management system specifically for machine learning pipelines. And they do a great job of capturing that endpoint. And then you can have different parts of the pipeline being well managed, but how do you actually bring it all together into one view, right? And hopefully there is where you catch that leakage. This is the idea that we would like to move towards, but a lot of it that we understand as well is you can't master every single aspect, but how can you actually become the backbone that other tools can pull into or push into, and then take that metadata and have somebody else be able to build that picture? And hopefully that's the idea over time. Yeah.
Any other questions? Well, I told you we'd learn something. I know I learned something. So thank you so much, Lisa. And before we go into networking, anybody have any job openings that you want to share with the group? I'm sure you guys have.
Yeah. No, we're always looking for talent, any sort of senior data engineers or those really experienced with distributed systems and biz dev. I really like that I'm a product manager in an open source company that's relatively small. That's super weird. But we're always looking for biz dev folks as well if you have a technical interest.
Cool. And then at Zillis, yeah, we've got our new sales VP.
Hello, everybody. I'm Sam. Great to meet you. I just joined last week, so it's just really excited to be here. Just as far as job openings go, we are opening up a few recs here, sales engineers in this area, in the Bay Area, and also in New York. So if you know anybody, please just let me know or get in contact with any of us. That's one, and also sales folks, but I don't think this crew, actually, you guys probably get a lot of salespeople talking to you, so if you know a good one, they're always trying to contact you, reach out to you. If you know a good one, just let us know. So those are the two roles as we continue to expand. So thank you very much.
Cool. And then, you know, we're open source projects, so give us a star, both of our projects. And actually, if you do give Milvus a star right now, we can do a raffle. I think